All right, so we're on to problem 18 of the final exam practice. And in this set of problems, parts A and B, we just want to sketch and describe this surface that the equations represent in R3. And so you should immediately see an equation like this: x squared plus y squared plus z squared equals 1, and know that this is just the equation of a sphere with center at the origin, so 0, 0, 0, and with radius equal to 1. Because of course this is in the proper form, so x minus 0 squared plus y minus 0 squared plus z minus 0 squared equals 1 squared, right? So our center, so this is a sphere centered at the origin with radius r equals 1. So this is a sphere. Okay, so we'll draw a picture of it. So our three-dimensional coordinate system, so x, y, z. And so this is just centered at the origin. So we have, try to make it look a little more like a sphere. I guess that's okay. But either way, it has radius 1 centered at the origin. Okay, and so this equation, x equals y squared, x equals z squared, rather, we know how to plot this in the zx plane, or xz plane, however you want to say it. But either way, this is just going to look like this in the xz plane. Because if you think about it, typically we see this equation like y equals x squared, and if you think about it, this is how that plays out in that situation. So either way, then this is essentially just a parabola in this plane, but if you think about it, y is unrestricted here, so the y coordinate is unrestricted. And so what that's going to mean is that when we draw our three-dimensional coordinate system, so I've just drawn a slice of that three-dimensional space, right? This is a two-dimensional slice at y equals 0. So for any value of y, so that basically will be going into and coming out of the paper, we basically just have a line sitting on each one of these points of this parabola. So it's going to be like some kind of half-pipe shape again, kind of similar to an example we did in class. But either way, let's try to draw it in our three-dimensional space. So we got our x, y, and z. Alright, so we're going to have something kind of looking like this coming out. So you should think about that as coming straight out of the paper along the x-axis. And then this also coming out of the paper sort of along the x-axis as well. And then we're basically going to have a version of this at every single point of y. And then they're all connected essentially like this. So this should look like a big mouth almost. Infinitely long mouth. So either way, it's a little bit hard to draw, but like I said, it looks like a mouth coming like this. Okay, so that's problem 18. All right, moving on.